Hi guys, good morning all. Am I audible guys? Everyone? Yeah, I hope everyone can understand, right? Everyone can able to hear my voice, right? So guys, we can start for the today's session. So let me share my screen and we'll discuss what we discussed in the last session first. Okay. So guys, in the last session we discussed about in the last week we discussed about the load balancer. What is the load balancer? How load balancer is going to work, right? What is the role of the load balancer in every application, right? And later how we can implement the load balancer by using the AWS cloud, right? That we discussed in the practical session and theoretical session as well in the last week. So today's agenda is we'll discuss about the Kubernetes. Let me write here what is the agenda of the today's session, guys. So I hope everyone is uh, uh, completed this load balancer practical session, right? Some of the peoples are already joined for this load balancer practical session. So please try to practice on this with the help of this AWS cloud. So it will help us to how load balancer is going to work, right? Now let's discuss about the Kubernetes today's, guys. So the today's agenda is introduction of the Kubernetes, right? Introduction of the Kubernetes, right? What is a Kubernetes? How Kubernetes is going to work, right? And what exactly the Kubernetes architecture is there, right? Then why companies use it for the real-time world, right? So we'll discuss about this point. Introduction of the Kubernetes. First point we discuss here, what is Kubernetes, right? Then later we discuss here why companies use it as real world need, right? Then later we discuss here the core concept of the Kubernetes, guys. What is the core concept in the actions, right? So we'll discuss about the pods, which is nothing but the application containers, right? Let me write here application containers. Later we discuss here service and load balancer, right? How load balancer is going to handle the request that you know already, right? So what are the services are available in the Kubernetes? How load balancer is going to handle the request, right? So everything we'll discuss here, guys. And later, what is auto scaling, right? By using the auto scaling, we can add or remove the pods, right? What is auto scaling? And we'll discuss here what is self-healing capacity, right? What is self-healing? So this is our today's agenda, guys. What is Kubernetes? Later, why companies use it for real world entity, right? Then later, what is pods, what is service and load balancer, what is auto scaling, and what is the self-healing capacity, right? So basically, what is the Kubernetes, guys? So Kubernetes is one of the software, right? Let me write here. The Kubernetes is nothing but one of the software, right? By using the Kubernetes, we can create the infrastructure or we can create the orchestrator platform for our application. Because I want to deploy my application on the server, right? So how to deploy our application? By using the pipelines, right? By using the Jenkins pipelines that we have the Jenkins pipeline, we have the server as well, right? But why we are going to use the Kubernetes for our deployment part of the application, guys? Because they have some advantages. First of all, let's discuss about the what is the Kubernetes, and then we can start for this advantages, guys, right? So first of all, the Kubernetes is one of the free server, or we can say that it is a free software. It is the free software, right? It is one of the free software which is developed by using the Go language, or we can say that Google is developed this Kubernetes, guys, right? It is a free software. Later, Google developed Google developed this Kubernetes. Google developed this Kubernetes, guys, right? Then Kubernetes developed using the Go programming language. In the Google, we have the Go programming language. With the help of Go programming language, we have created this Kubernetes architecture, guys, right? So using Go programming language, KTS is developed, right? Then Kubernetes will provide the orchestration. The Kubernetes is nothing but the orchestration, and Docker is nothing but the containerization, right? So Kubernetes provides orchestration platform, right? Kubernetes provide the orchestration. Then what is the orchestration, guys? Orchestration is nothing but the management, right? So Kubernetes provide the orchestration. So Kubernetes will use to manage the containers. But inside of the Kubernetes, we have the containers, and containers have the application. Containers contain the server application. I mean, our application is deployed on the container. Container is nothing but the server, right? And those server which is managed by using the Kubernetes, guys. So Kubernetes is a free software which is developed by using the Google. I mean, Google is developed this Kubernetes. Then later, using the Go programming language, Kubernetes is developed. Then Kubernetes provide the orchestration platform, that is nothing but the management. And the Kubernetes have the ability to manage the containers. Kubernetes is used to manage the containers. Now, what is the managing containers, guys? Managing containers is nothing but the we can create the container, we can stop the container, we can start the container, right? We can create the container, we can start the container, we can stop the container, then we can scale up the containers, and we can scale down the container, right? So Kubernetes is free software. Google developed by this Kubernetes using Go programming language. We can develop this Kubernetes, guys. Then Kubernetes provide the orchestration, and Kubernetes which is used to manage the containers. Containers are nothing but the servers, right? So we can create the containers, we can start the containers, we can stop, we can scale up, and we can scale down the containers, right? Then what is the advantages of the Kubernetes? Let's discuss about the real-time advantages first, guys. Are you understood about this Kubernetes theoretical part, guys? Which is the software developed by Google, right? Using the Go programming language, we can develop the Kubernetes, provide the orchestration, that is nothing but the management, and by using the Kubernetes, we can manage the containers, right? So that is nothing but the Kubernetes, guys. Then why Kubernetes is very important, right? What is the use of the Kubernetes in the real entity on the real world, right? Why Kubernetes is used for our deployment part of the application, that is very, very important, guys. Let's discuss about we can start discussion related to the big billion sale, guys, because currently in the Flipkart offers for the big billion sale, right? Current days like big billion sales is going on, right? So let's discuss about the normal scenario first. Before the sale, what happened, guys? I mean, before this sale, it means we have the normal days for the normal days for the Flipkart, right? So on the normal days, only the limited numbers of customer is going to visit for the Flipkart, guys, right? So the websites run with only like let's consider website is going to run with the only two front end pods and two back end pods with database, right? Let's discuss. We have only the two front end pods. Pods is nothing but the server, right? Two front end pods, two back end pods, and we have the one database. So this is enough to handle the traffic for the small. I mean the small coming requesters, right? Before the sales, we have the normal request, right? On the normal request, we have the two front end pods, two backend pods, and one database to handle the request. Let me show you with the diagram, guys, so you can easily understood what I'm trying to say, you guys. Let's discuss about, there is one scenario. Let's suppose we have the user here. Here one user. This is our second user, and this is our third user, right? So what does user? User is going to fire the request. In the last session, we discussed about the load balancer, right? Here we have the load balancer, guys. Here we have the load balancer, right? Load balancer is going to fire the request to the server. So server have the front end pods, server have the back end pod as well, right? Here the front end pods, and here is the back end pods, right? And here we have the database, right? Let me write here. This is our user. This is the user first, user second, user third, and this is our load balancer, right? This is our front end pod. Wait. Right? Front end pod 1, and this is nothing but our front end pod second. Try to understand this diagram, guys. Then this is our backend pod. Then what is the pod? We will discuss here. Okay. This is our backend pod first, and this is our backend pod second, right? And this is nothing but our database. Then what will happen in the normal days? Suppose this is the website for this Flipkart, guys. In the normal days, user is going to fire the request, right? So number of users are coming here, right? User is going to fire the request. First user is going to fire the request. Second is going to fire the request. Third is going to fire the request, right? Then load balancer. What is the role of the load balancer, guys? Load balancer have the round robin technique, right? That we discussed in the last session, guys, right? Load balancer is going to fire the load balancer is going to accept the request by the user. Then later load balancer is going to distribute the request on the multiple servers. Let's suppose we have the two servers, front end pod 1, front end pod second. It means there we have the two servers, right? This is our first server and this is our second server. Let me coach it to in this server number 1, and this is our server number 2. Okay, so what happened here, guys? Load balancer is going to distribute the requests on the multiple server. Let's suppose that there we have the two servers only. The first server contain, this is our server number first, right? The first server contain the front end pod, and second server contain, first server contain front end pod 1 and back end pod 1. Second server contain front end pod 2 and back end, this is the back end. Okay, so wait guys. Right. Right, this is nothing but our backend pod second, right? So every time user is going to fire the request, load balancer will accept the request. then load balancer later distribute the request on the multiple server. This is nothing but the load balancer. So load balancer is going to distribute the request on the multiple server. First request is going to the first server, second request is going to the second server, right? Then later our third server, third request is going to the again first server. Fourth request is going to the again second server, right? That is nothing but the round robin technique. Later front end is going to communicate with our backend application. Here front end is communicate with our backend. Here also for front end is going to communicate with our backend, and later backend is going to communicate with our database guys to fetch the data from the database, right? So this is the flow of our application. Normally how the flow is going to work: user is fire the request, load balancer distribute the request on the multiple server, later server contain the front end pod, server contain the back end pod, front end pod communicate with our back end pod, back end is going to communicate with our database, and whatever user is going to fire the request according to the front end and back end pod is going to communicate with our database, and database front end is fetch the data, and accordingly user is going to accept the data, right? User will fulfill the data whatever user is going to fire the request. Suppose user is going to search the iPhone 17, right? Accordingly front end communicate with our backend, and backend will get the data from the database, and user will fulfill the data with the model of our iPhone 17, right? And this is the normal days, right? So now what will happen in this current trend, guys? It means, let's suppose currently big billion days are coming on, right? Going on, right? Let me show you one more diagram for you guys. Let's suppose so before sale we have this situation: the user is going to fire the request, right? Let's suppose lack of user is going to fire the request by daily purpose, daily basis, right? Daily 1 lakh user is going to fire the request, but at this moment, current moment, the users, multiple users are going to fire the request because we have the sales are available on this Flipkart, right? Accordingly user will reach out to the Flipkart application, and user is going to fire the request, right? For this purchasing any products, right? So for that the situation is going to change. Multiple user is coming here: user first, user second, user third, user third, later fourth user, fifth user, right? Sixth user. Again there we have the load balancer here, right? Again there we have the server here, and server contain the front end pod, and server contain the back end pod as well. This is the front end, this is the back end pod. Let me complete with this diagram, guys, then I'll explain this one. Right, this is our back end. Front end, this is our back end, right? So here is the user, right? User first, second user, then here we have the third user, fourth one, fifth, sixth, right? And here we have the again load balancer, right? This is our front end pod. First, front end pod second, here the third front end pod, again fourth one, and here we have the fifth one. Similarly we have the backend pod as well. right? Backend first, second backend, third one, fourth and fifth, right? Again, we have the same database, right? This is our database, right? So let's consider here the normal situation and let's consider here the big billion situation, right? I mean, wait guys. So this is our normal situation. Let me write here, or we can say that normal days are going on, right? Right? Normal days, and here we have big billion days. Now what will happen, guys? On the normal days, only limited number of customers is going to visit to this Flipkart application, right? Right. So that's why the website is run with just only these two pods. I mean, two. We can say that the two pods, like pods, is nothing but the server one, server two, right? So two pod contain the two front end pods, right, and two back end pods, right? Plus we have the one database, right? This is enough for the handle the small traffic, right? It is also save the cost, because whenever we are trying to increase the number of server, it will impact on your cost, guys, right? We need to give the rent of to the AWS, right, on this server, according to this server, right? So in the normal days, we have the two pods. The pod number first, we have the front end pod and back end pod. Pod number second, we have the front end second pod and front end backend pod, right? And we have the one database. This is enough for our normal days, guys. Later, during this big billion sale, what will happen, guys? Now comes with the big billion sales, suddenly lack of customer come online at the same time, right? Then if we had the two pods, or we can say that the two server running, the website is going to crash, right? At the same situation, big billion sales is going on and we have the two pods. Then what will happen, guys? What will happen, guys? Our website is going to crash, right? But Kubernetes is a smart. It notices that how load balancer, or notices high loads of our application, right? Because number of requests is coming here, right? So when the number of requests are coming, then how we can handle those requests, guys? So here we have the Kubernetes. Kubernetes have the advantages of the load balancer, guys. But Kubernetes is smart, so automatically increase the number of pods here, guys. Right? We haven't increased these pods manually. The Kubernetes is going to increase the pods automatically. For example, it increased the pods from 2 to 5, right? Because we have the two pods first. Later, we those pods is going to increase with the 5, right? So then after that, load balancer is going to distribute the requests according to that, because load balancer is going to transfer the request to the first pod, second pod, third pod, fourth pod, and fifth pod. Again, when request is comes here, then load balancer is also work like a round robin. Again, load balancer is going to fire the request for the six requests to the first pod again, right? Then who is going to handle those pods, guys? By using the Kubernetes, we can do that, right? Because we have the lots of requests are coming here. Then Kubernetes is going to check the request, how load is coming here, right? Because our load balancer is not going to handle those requests, because we have the lots of requests in this big billion days. So at this moment, the load balancer is distribute the request, but we don't have any enough server. At this moment, Kubernetes is going to check the loads. And according to that, Kubernetes is going to increase the number of pods. That is nothing but the auto scaling here. Are you guys clear about this point? Everyone? Everyone?
Yes.
Yeah. So again, user is going to fire the request, right? Here we have the load balancer, and load balancer is advantages of the Kubernetes, guys. It means that we can say that this is nothing but our K8s orchestration. right? So previously we have the normal days, we have the Kubernetes, but we don't have any maximum request here. Those are because this is the normal days. At this moment, we have the enough request. I mean, we have the 1 lakh of requests in the one day. At this moment, we have the 2 pods only, and 2 pods is enough for our traffic, guys. This traffic to handle this traffic. But at the moment of the big billion days, the number of requests are increasing, right? 1 lakh to the 10 lakh. So for this, those 10 lakh requests, we required here the number of server guys, right? And those server will handle by the Kubernetes. The Kubernetes is going to check the number of load are coming by the users, and according to that, Kubernetes is going to increase the number of pods, right? Again, the pods is nothing but the server, so number of server is going to up here, right? Because we have the 5 times of request daily. We have the 1 lakh of requests, and nowadays we have the 5 lakh of requests are coming by the user on our application, on our Flipkart application, right? So accordingly, pod is going to up, and this is the responsibility of the Kubernetes to increase the number of pods, right? And that is nothing but the auto scaling, guys, right? So according to that, load balancer is going to distribute the request to the first pod, distribute the request to the second pod, distribute the request to the third pod, distribute the request to the fourth and fifth pod, right? Later, again, front end is going to communicate with our back end, right? Front end is going to communicate with our back end, and again, back end is going to communicate with our database, right? And this is the flow of our every application, guys. So here, backend is going to communicate with our database, and user is easily get the details from the database, guys, right? Then what will happen after this big billion days? We have the normal situation. Normal situation have enough load. Enough servers, right? After that big billion days, Kubernetes is going to increase the number of server. So what will happen when we increase the number of server? Automatically, your rent is going to up. I mean, you want to like get the server from the AWS cloud, right? And Flipkart is going to, Flipkart will going to pay the amount to the AWS server because Flipkart have the better advantages of those server, guys. Because Flipkart is going to work like smooth, because user want the details from the database. User is going to book the, purchase the products from the Flipkart, right? Accordingly, user will get the details from the database because we have smoothly get the details from the database because we have the number of servers are available here. Then what will happen after this lag, guys? After this sale, right? After the 7 days, our big billion days is going down, right? Our big billion days is closed. Then after what will happen, guys? Again, after the sale ends, traffic comes back to the normal days, right? I mean, every day now 5 lakh request is coming on this application, and after this sale, again our normal days is going on, like 1 lakh request is coming on this Flipkart application, right? If we keep the 5 pods as it is, then what will happen, guys? The company will waste the monies, right? In the normal days as well, if we have the number of pods, if we have the number of, 5 pods is available there, then company will going to the loss because company will waste the monies. So Kubernetes will automatically remove the extra pods here, guys. Again, Kubernetes comes into the picture. Kubernetes will check again the number of user is going to fire the request on this Flipkart application. According to that, Kubernetes is going to remove the extra pods from here, guys. It means again Kubernetes is going to remove those extra pods, and again Kubernetes will run with those 2 pods only, right? So this is called as a scale down process, guys. Are you guys understood about this point? First of all, Kubernetes is going to scale up because we have the number of requests are available. We have increased the number of requests. So for smoothly running our application, Kubernetes is going to up the number of server. And once our sale is going to down, or scale is going to complete it, later Kubernetes is going to decrease those pods, or Kubernetes is going to delete those pods. And once again, we have in the normal situation because saving our cost, guys. right? When traffic is low, again Kubernetes is going to down those number of pods, and we have in the normal situation once again, guys. That is nothing but the scaling down. So it means Kubernetes acts like a smart store manager. So that's why we are saying that Kubernetes is nothing but the management manager. Okay. So Kubernetes provide the orchestrator. Orchestration is nothing but the management. So Kubernetes is used to manage the containers. Kubernetes is going to create the container. Kubernetes is going to start the container. Kubernetes is going to stop the container. Also, Kubernetes scale up the containers according to the user request. Because we have the lots of requests are coming from this websites, guys, coming on this website, guys. Yeah, right? So accordingly, Kubernetes is going to scale up the servers, and later, once our big billion days is completed, later once again we have in the normal situation, Kubernetes will delete those servers, guys, because of the cost saving, right? That is nothing but the scale down. Are you guys clear about this point, everyone? So that's why this is why Flipkart, Amazon, Swiggy, Zomato all use this Kubernetes application, guys. Are you guys understood about this point, everyone?
Yes.
Yeah. So let's discuss about the Kubernetes advantages, and those are the advantages of the Kubernetes, guys. Let me write here the advantages over the Kubernetes. What are the advantages of the Kubernetes, guys? And this is the interview question. Every interviewer is going to ask this question. What are the advantages of the Kubernetes? First of all, Kubernetes is a software developed by using the Google, right? Programming language is Go. Then Kubernetes provide the orchestration, which is nothing but the management. Kubernetes is used to manage the containers. It is help us to create the container, start the container, stop the container, scale up the container, and scale down the container, right? Then what is the advantages of Kubernetes, guys? The first advantage is auto scaling. Then what is the auto scaling, guys? That we discuss here. What is the auto scaling, guys? Based on the demand, container count is going to increase, right, or decrease. That is nothing but the auto scaling. So auto scaling have the scale up and scale down. Okay, so auto scaling is nothing but based on the demand, the container count is increased, and based on the demand also container count is decreased, right? That is nothing but the auto scaling. Let me write here. We can say that based on the demand, the container count is increased or decreased, right? The container count is increase or decrease, right? That is nothing but the auto scaling. It means we have the scale up, right, and we have the scale down. So what is the scale up? Scale up is nothing but the increase the number of containers, or we can say that the servers, right? And scale down is nothing but the to decrease the number of servers, right? And this is the first advantages over the Kubernetes, guys. The first advantage is auto scaling. Based on the demand, we can increase the number of containers and we can decrease the number of containers as well, right? This is our first advantages of the Kubernetes. So accordingly, Kubernetes will handle the request and our application is going to smoothly application is going to behave. User is going to fire the request accordingly. User will get the data from the database and user will fulfill the request. At this moment we have the 5 lakh of user. At this moment we have the 1 lakh of users, right? At this moment of the 1 lakh of request, user is also getting the details in the data from the database, right, within a fraction of second. And this moment also user will user will get the data from the database within a fraction of second because of auto scaling capacity, right? from the Kubernetes. So Kubernetes have the advantages of the auto scaling, and later Kubernetes have the advantages of the load balancing as well. Right? So there is no need to create the load balancer separately, because Kubernetes have the advantages over the load balancer, guys. So load balancer will help us to distribute the load on the multiple server, right? Once auto scaling will increase the number of pods. Accordingly, load balancer is going to distribute the request, because load balancer have the round robin technique. Load balancer is knows about those registered servers, guys, because once auto scaling up the request, sorry, up the servers, those server is going to register inside of the load balancer. Later load balancer is knows about we have the 5 more servers are available. Accordingly, load balancer will transfer the request from those to those servers, guys, right? First of all, load balancer have only 2 servers. Those server already registered inside of the load balancer. Accordingly, load balancer will work on this, right? Load balancer will distribute the request first to second, second to first, first to second, right? Later auto scaling will increase the number of server, and those server registration will happen inside of the load balancer, and load balancer again distribute the request from 1 to 5, right? So there is no need to create the load balancer separately. Once you can install, or once you can set up the Kubernetes orchestration, automatically you will get the auto scaling advantages as well as the load balancing. So what is the load balancing, guys? What is the load balancing? Load balancing is nothing but Mhm. What is the load balancing,
Sir,
guys?
but load
Yes,
balancing is distributed the request in round robin technique, means one to second, second to one.
right, right,
Uh,
right.
or Sir, I have one doubt. If load balancing is working on round robin technique, but Kubernetes have like this type of technique, how to increase the ports or server, and how to register. Okay, I got the 1 lakh request, and after
Hmm.
that need to increase the server. But
Hmm.
this property is available in Kubernetes, or it working on the any techniques.
Can you just come up again? Not understand.
uh, in load balancer have a round robin technique.
Right,
That's why
right,
load balancer understand ki server request come first on first
right.
server and second for second server. But in Kubernetes, how to
Hmm.
know ki after 1 lakh request need to count.
See. Yeah, yeah, I got your point. So see, guys, the Kubernetes orchestrator. Can you just mute your mic? Yeah, okay. So Kubernetes orchestrator contain the nodes. The first one is control node, and second one is master node. I'll show you the diagram. I already opened this diagram here. Let me show you the diagram. We'll discuss on this as well. Yeah. So see, guys, this is our Kubernetes architecture, right? This is user interface. This is kubectl. The control plan is going to work on this request, guys. API server is nothing but API server will receive the request which is comes from the user, and API server is going to calculate the request. How many requests are coming from the user, right? Because user interfaces communicate with our API server. So API server is going to know about we have today we have the 1 lakh of requests. So API server will communicate with our load balancer, and accordingly load balancer is distribute the loads, right? Later in the second day we have the 5 lakh of requests is coming from the user. Accordingly API server will work on it. API server will know we have the 5 lakh of requests. Yesterday we have the 1 lakh requests, but today we have the 5 lakh requests, right? So accordingly, a control panel is going to communicate with our auto scaling. Auto scaling is going to increase the number of pods here. Pod number 1, 2, 3. We have the 3 pods here in this Kubernetes architecture. Later, we will get the new 2 pods because we have the 5 lakh of requests again here. Accordingly, auto scaling will increase the number of pods, and again load balancer will distribute the request because those pods is also registered in the load balancer, and load balancer will work like a round robin technique. So API server is main role for here, guys. API server have the role to check the request. How many requests we have here? So API server is available inside of the control plan. We will discuss later about this point, guys. Don't worry about this. I'll clear everything here. Okay, don't worry about this. How request is going to come? how distribute the request by using the load balancer, right? How we can know about the multiple requests which are coming from the user, right? That we will discuss later, guys, because we need to check this Kubernetes architecture. What is the API server? What is the scheduler? What is the controller manager? And what is the etcd? This is very, very important, guys. Control panel will control everything behalf of Kubernetes, guys, because Kubernetes will know about everything. How many requests which are coming from the user, right? How many servers we have here? How we can handle the number of requests within this enough of server? Accordingly, Kubernetes will work. I mean, Kubernetes will increase the number of pods by using the auto scaling. So how those we can handle, guys? By though we cannot handle anything. The handle by those can handle by using this control plan. That is nothing but the master node. So master node have the I mean have the accessibility to increase the number of pods and I mean increase the number of pods according to the user interface request. So everything is a setup here. Don't do anything manually, guys. Everything is a setup. Only we need to install the Kubernetes. We need to set up the Kubernetes. We need to connect Kubernetes to the Jenkins. We need to connect Kubernetes to the Docker container and everything, right? Only we have the role to communicate with Kubernetes in our application, right? So Kubernetes have the advantages. We will discuss about those architecture, guys, later. First of all, we'll discuss about the advantages of the Kubernetes. First advantage is auto scaling. Based on the demand, container count is going to increase, and based on the demand as well, container count is going to decrease. If you don't have any much more demand, then container is going to decrease because of cost saving. So that's why the what we can say that e-commerce companies are going to purchase. I mean, companies are going to use the Kubernetes for their application, right? Then the second one is load balancing. Load balancing will work like load will be distributed to the all containers, right? That is nothing but, and by using the round robin technique, that is nothing but the load balancing, right? And the last advantages of the Kubernetes, guys, that is very, very important, which is nothing but the self-healing capacity. Then what is the self-healing, guys? Let's consider here we have the big billion days. We have the 5 nodes are going to, sorry, 5 pods are going to up by the auto scaling because we have the number of requests are coming from the user, right? And let's suppose suddenly suddenly one pod is going to decrease, guys. This pod is, we have some server issue, and this pod is going to I mean this pod is going to down, okay? But we required the 5 pods, and because of number of requests, but suddenly this pod is going to down, or this pod is going to crash because of the server error or any error, any kind of error here, and accordingly our pod is going to down. Then what will happen, guys? We have only 4 pods, right? And will not handle those 4 pods for those number of requests, guys, because we have the 5 lakh of requests in these days, right? So at this moment, Kubernetes is going to check the health of those pods, guys. Every time Kubernetes is going to check the health of those pods. Kubernetes is going to communicate with the first pod. The first pod is health is good. Then first pod is, first pod will work for our application to get the data from the database. Also, again, Kubernetes is going to communicate with the second pod, is going to check the health of this pod. Every time Kubernetes is going to check the health of those pod, guys. If our first pod is going to down in any kind of error, Kubernetes is going to check the error. Kubernetes is going to check the error. Kubernetes confirm this pod is going to down because of server error. At this moment, Kubernetes is going to create one more new pod for this application, guys, for inside of this orchestrator. It means that is nothing but the self-healing capacity. If our one pod is going to down, one pod is going to crash automatically. At this moment, Kubernetes is going to create one more pod instead of this pod. It means we have the replacement for this pod, guys, and that is nothing but the self-healing capacity. It means if we any if, or we can say that if any container is going to crash, then it will replace with the new container that is nothing but the self-healing capacity. Are you guys clear about this point? Let me write here. If any pod, or we can say that if any container got crashed by any reason, then it will replaced with new container, right? Then it will replace with new container that is nothing but the self-healing capacity, right? So we have the advantages of the Kubernetes, guys: auto scaling, automatically scale up, scale down, load balancing according to the auto scaling, how much number of how many servers are going to up, those server is registered inside of the load balancer, and load balancer will distribute the load on the multiples, those registered server, right? And later if any container is going to crash, then it will replace with a new container that is nothing but the self-healing capacity, guys. Are you guys clear about those advantages? Any doubts on it? Yes, guys, any doubts? Mm-hmm.
No doubts.
Okay, everyone understood about this architecture, guys? Architecture, it means the advantages only, right? So Kubernetes is a free software developed by using the programming language. Kubernetes provide the orchestration, that is nothing but the management. It will manage the everything, manage the containers, to create the container, start the container, stop the container, scale up the container, scale down the container, right? Then Kubernetes have the advantages. The first one is auto scaling. Based on the demand, container count is going to increase, right? Based on the demand. If you don't have any demand, then container count is going to decrease, right? Then load balancer, it will distribute the load on the multiple server. Then we have the self-healing capacity as well. If any container is going to crash, then it will replace with a new container, right? So that is nothing but the advantages. Now there we have one question, guys. What is the Docker and what is the Kubernetes? Or we can say that the Docker versus Kubernetes, right? Because we know Kubernetes is nothing but the orchestration, right? Kubernetes is nothing but the orchestration. Let me write here: Docker versus container. Then what is the Docker, guys? I'm not giving the training on this Docker right now, but I'll give you the small demo for this Docker versus container, where the Docker is available. Sorry, Docker versus Kubernetes, guys. Sorry, guys, Kubernetes, right? Where the Docker is available inside of the orchestration, right? So Docker is nothing but the containerization platform. Let me write here. This is nothing but containerization platform. Docker is nothing but the containerization platform, right? And the Kubernetes is nothing but the orchestrator platform, right? Then what is the containerization, guys? Let me show you this diagram again. Okay. So this is our Kubernetes architecture. How Kubernetes looks like. The Kubernetes looks like that, right? So you can able to see here the container first, container second, container third, container here. In this pod 1 we have the 3 containers, in this pod 2 we have the one container, in this pod 3 we have the 2 containers, and here we have this Docker, guys, right? Then what is the Docker, guys? Docker is nothing but the containerization platform. Those are the container. For those container we have this platform, guys, right? Docker is nothing but the containerization platform. Then what is the containerization platform, guys? What is the containerization platform? Which is nothing but the packaging our code and dependencies as a single unit for our execution. That is called as a containerization. Let me write here. We have the Java application, right? And I want to make the Java application to the Docker image, right? And I'm giving the command, I'm firing the command, and our application, our Java application make our Docker image. I mean, our Java application convert into the Docker image, right? Then what is this image, guys? What is this containerization, right? That is nothing but the packaging our application code and dependencies, right? Packaging our application and dependencies as a single unit. Let me write here as a single unit, right? Packaging our application and dependency as a single unit for execution. Execution is called as containerization, guys, right? So that is nothing but the containerization. Containerization is nothing but the packaging our application code and dependency as a single unit. Like suppose we have the Java application. I want to convert this Java application into the jar file. Then how we can make this, case? By using the Maven, right? Maven or Gradle. With the help of a Maven, Maven is one of the building tool. According to the Maven, we can build our application and you will get the jar file of our application, guys, right? Similarly, for this Docker is nothing but the containerization platform. The containerization is nothing but the packaging our application, complete application. So Docker contain our complete application code and dependencies as a single unit. And this unit is stored here, guys. It means our application code and dependencies are stored here, right? That is nothing but our Docker platform or containerization platform, right? So every container have the same code, right? Because we have the auto scaling. Auto scaling is going to up the number of containers, right? Because we have the lots of requests are coming from the user. Accordingly, API server will receive the request and auto scaling will increase the number of containers, and those container is going to communicate with our database, right? Then what about this control plan, and what about this worker node and worker node second? We'll discuss here, guys. First of all, try to understand what is the containerization. Containerization is nothing but the packaging of our code and dependencies as a single unit, right? For this execution, that is called as a containerization. And Kubernetes is nothing but orchestrator platform. Orchestrator means managing those containers. Let me write here. Then what is the Kubernetes? Kubernetes, guys. Kubernetes is nothing but the orchestration platform, right? So what is the orchestration, guys? Orchestrator, it means orchestration is nothing but orchestration means managing, managing the containers. Managing the containers, right? That is nothing but the orchestration, right? Then who is going to manage those containers, guys? The Kubernetes is going to manage those containers, because Kubernetes is nothing but the orchestrator. So what does orchestrator? Orchestrator is going to manage those containers. Manage is nothing but create the container, start the container, stop the container, scale up the container as per the requirement, scale down the container if we don't have any much more requirement, right? That is nothing but the managing the container. So Kubernetes is nothing but the orchestrator, Docker is nothing but the containerization platform, and for those containerization management, orchestrator is going to work on it, right? For create, start, stop, delete, scale up, scale down, everything is going to manage by the orchestrator, guys, right? It means inside of the Kubernetes we have the containerization platform, right? Now let's discuss about this architecture, guys. Let me show you this let me explain about this architecture, guys. What is the control plan, what is a worker node first, and what is a worker node second? We'll discuss about this, guys. Are you guys understood about this orchestrator and containerization? Any doubts on it? Everyone? Yes, guys. Any doubts? Yeah. Anything else? Yeah. You can raise your hand. Otherwise, you can unmute yourself, please. but try to understand everything about this orchestrator, guys, because this is very, very important. Every single deployment, Kubernetes works smartly.
Sir, I have one doubt.
Yes,
Is a Docker image is a complete project file?
right, right. Complete project. It means it contains the front end as well as the back end, right? That we discuss here in this our diagram. This
Yes.
is nothing but our packaging, right? Front end application as well there, back end application as well there, and this is our platform, containerization platform. Complete application is going to rest on this platform, guys, right? So Java jar file contain only the Java application, right? But Docker image, whenever we try to convert our application into the Docker image, at this moment we have image contain the application code, application dependency, as well as the application front end part, right? And here is our complete application, front end and back end. And this is the images for our application, guys. It means this is our containerization platform, and containerization contain the container first, second, third. Every container have the same code, because we have the lots of requests are coming from this user, and accordingly load balancer will distribute the requests on the multiple servers, right? Yeah, okay. Let me start for this architecture, then you can understood better about this point, guys. Let me write here Kubernetes architecture. Actually, this is not possible to write this I mean, paint this diagram. So that's why I'm just opening this Google diagram, guys. This is our Kubernetes architecture. Okay. So Kubernetes follow the cluster architecture. This is our cluster architecture. Okay. That we have the cluster up, cluster down, right? So Kubernetes cluster means group of server will be available here, guys. We have the group of servers that we discuss here. We have the group of server. This is the first server group. This is the second server group. This is the third server group, right? This is the fourth one. This is the fifth one, right? That is nothing but the cluster, right? So Kubernetes cluster, we will have the master node, and Kubernetes cluster, we will have the worker node. That is also nothing but the control plan, also nothing but the master node. Keep remember about this point, guys. Control plan is nothing but the master node, and we have the worker node. The interview is going to ask one question every time. What is the master node and what is the worker node in the Kubernetes? And you should know everything about the master node first, because master node is nothing but the control plan, and every request is comes inside of the control plan first. Accordingly, the request is going to calculate it, how much requests are there, and those requests is going to transfer to the worker node, and worker node will communicate with our containers will communicate with our database, and database will from the database will pull the response, and accordingly will get the response, guys. Sorry, guys, response, right? So cluster, Kubernetes follow the cluster architecture. Cluster is nothing but the group of servers, right? Cluster is nothing but the group of server. So cluster, we will have the master node, that is nothing but the control plan, and cluster we have the worker node. It means this is nothing but the complete cluster, right? This is nothing but the complete cluster. Cluster contain the control plan or master node, cluster contain the worker node, right? The meaning of the cluster is nothing but the group of servers, right? This is one of group of server, this is the group of server, this is the group of server, right? This is also server, right? Master node is also one of the server, or we can say that the group of server, right? So let's discuss about the one by one about this API server, scheduler, control plan, etc. Let me write here first. Let me write here Kubernetes cluster component. KTS cluster component. So the first one is cluster component. First one is control plan. See, guys, this is nothing but our user interface. Okay, front end part of our application. Front end is going to fire the request. right? Control plan, or we can say that the control node as well, control node. So you can easily understood about this differences between this worker node and control node. Okay, so I'm going to write here the control node. So control node is nothing but master node, right? So what about this master node, guys? Master node contain API server, right? Then what is this API server, guys? The master node contain first API server, right? Then what is this API server, guys? What is this API server? So API server, first of all, whenever our user interface is going to communicate with our control plan, right? So there is one scenario. We are trying to deploy our application, right, using the Kubernetes. We need to communicate with our control node first, right? Every time whenever we deploy our application on the Kubernetes, every time we need to communicate with our control plan or master node, right? At this moment, we will have the kubectl as well, right? Then what is this? User interface is nothing but the user is going to fire the request. Then what is the kubectl, guys? We will use the kubectl is nothing but the CLI, right? CLI is nothing but the command line interface. This is our user interface. This is our CLI. It means command line interface, which is help us to communicate with our control plan. It means we have two options to communicate with our master node or control plan, guys. First one is user interface. Second one is command line interface. Those both are by using, by using those one, we can communicate with our control plan, right? Try to understand, this is our user interface, this is our CLI, right? So a simple language, we have the Java application, right? We can run our Java application by IDE. Also we can run our Java application by the command line interface, or we can say that the CMD, right? To run our Java application, we can write the command, accordingly we can run our application. Also we have the facility in our IDE. We have the IntelliJ, we have the Eclipse IDE, we have the Spring Boot IDE. Accordingly we can start our Java application, right? Accordingly, the Kubernetes architecture, we have the user interface, we have the kubectl, and by using those both one, we can communicate with our control plan. Let's enter into the control plan now, guys. The control plan, by using the UI, by using the CLI, we can communicate with our control plan, right? Then control plan contain the API server. Then what does API server? So API server is exactly near about this user interface. It means whatever user is going to fire the request, API server will receive the requests which are given by the kubectl or UI. Okay. So suppose user is going to fire the request from the kubectl. At this moment, API server will receive the request, right? Here also, user is going to fire the request through the UI. The API server is first of all comes into the picture, and API server will receive the request here, right? So API server will receive the requests which are given by the kubectl, and it will store in the database. Let me write here for the first about this API server, guys. API server API server will receive the request, or we can say that the receive the incoming request, right? So let's compare this diagram, guys, with the help of API. Whenever user is going to fire the request, first of all here API server is comes into the picture. Here we have the API server, right? API server will receive the request first, right? So API server will receive the incoming requests which are fired by user interface, or we can say that the given by kubectl. Kubectl is nothing but CLI, right? CLI is called as a command line interface, right? So CLI, and this request is going to store. This request is going to store inside of the database. So there we have the Kubernetes internal database is available. That is nothing but the etcd. The second one is etcd. Just give me a second, guys. Okay. So first of all, API is going to, sorry, kubectl is going to fire the request accordingly. Our API server will receive the request, and this request is going to store inside of the internal database of the Kubernetes that is called as a etcd. Are you guys understood about those API server and etcd? Then what is the etcd, guys? Etcd is the internal database of the Kubernetes cluster. Let me write here etcd. What does etcd, guys? Etcd is an the internal DB, right? Internal DB of Kubernetes cluster, right? Internal database of the Kubernetes cluster, right? Then what does the etcd, guys? Etcd will store the incoming request. First of all, API server will receive the request. Later, those requests are going to store inside of the etcd. Etcd is nothing but the internal database of the Kubernetes cluster, guys, right? This is very, very important. Etcd is the internal database, right? Every interview is going to ask that like of question, what does the etcd? What is the role and responsibility of the API server? API server always communicate with our kubectl. Then what is the kubectl, guys? Kubectl is CLI. Accordingly, user is going to fire the request and receive the request by API server. Those requests is going to store inside of the etcd. Are you guys understood this point? Everyone?
Then API server only is going to create the Kubernetes object, right?
Yeah,
Using the
exactly.
kubectl command.
Right. Correct. And this object is going to store inside of the etc. It means object contain the every information about the request, right? Because whenever you try to, whenever you try to create or try any kind of request, this request is going to store inside of the object format. Object contain the JSON format, and JSON is going to store inside of the etcd. So now Kubernetes have the better idea about the user request. Now Kubernetes is understood what user is going to fire the request, right? The user want the purchase one iPhone, right? iPhone 17. So this iPhone 17 request is received by the API server, and this is going to store inside of the etcd in the JSON format, right? So this is the internal working of this Kubernetes, guys. So you need to understood at least API server will receive the request and store inside of the etcd, right? Then what about this scheduler, guys? What does this scheduler? Let me write here scheduler. What does this scheduler, guys? The API server will receive the request, right? Later, scheduler will identify the pending request from this etcd, right? API server will receive the request and store inside of the etcd. Then what does the scheduler? Scheduler will identify the incoming request which are available in the etcd, and those requests in the pending state. Because we have the 10 requests here, 5 requests are 5 requests are processed. Processing is completed. User is received the incoming. User is received the response, but we have the 5 more requests which are pending inside of the etcd, and those are handled by. Those are checked by using the scheduler. So scheduler every time is going to check what are the pending requests which are available in the etcd, right? We have the 10 requests, 10 inside of the 10, in between 10, 5 already completed and 5 are pending state, right? So object is a key and value is the state of this request. The pending state, completed state, in process state, or failing state, right? So scheduler is going to check the state of this request, and accordingly scheduler is going to work on it, right? So API server receive, etcd contain the request, scheduler is going to check the request. Again here, scheduler is going to check the, check the pending request, right? Let me write here. Scheduler will identify, or it is identify, the request, or we can say that the pending request, right? It is identify the pending requests, right, which are available in available in etcd, guys, and it will identify the worker node to schedule the task. Later also it will identify it will identify worker node, right? Worker node to schedule the task on server. It means when scheduler will know about our pending request, at this moment, again, scheduler is going to identify the worker node. Scheduler is going to check who is, which node is right now free for our incoming request, guys, right? We have the pending request. Suppose we have the two requests are pending here, etcd. The scheduler is going to check the pending request, and this request is going to assign to the worker node. First of all, scheduler is going to check the nodes, which node is free for our application or which node is busy. Suppose this node is busy for another request. At this moment, scheduler is going to move to the second worker node, and scheduler is going to assign this request to the second worker node, guys, right? It means suppose this is the busy for another request, so at this moment scheduler will assign this request to the second worker node. Second worker node right now is a free, right? So API server will receive the request. Etcd contain the objects, it means request in the pending state or completed state. Those are checked by the scheduler. Later scheduler will assign the request to the worker according to the availability of the worker. Scheduler etcd. Any doubts on this API server scheduler etcd? Please raise your hand. Otherwise, just unmute yourself, guys. Any doubts on this? Yes. Yeah. Any doubt, guys? Nawaz, your camera is on. You can mute your camera, please. Yeah. Okay. If you don't have any doubt, then we can proceed for this control manager, guys. Right. So now you can better understood about this API server scheduler and etcd, right? Now, here what will happen in the also we have some other things for the scheduler, guys. So scheduler will identify the worker node using the kubectl, okay? Sorry, kubelet. So this is once again comes into the picture, guys. Okay, scheduler is not going to work independently. Scheduler have some dependency by the kubelet. Because what is a kubelet? Let me write here the kubelet as well, because this is very, very important. Because scheduler will not going to check the worker node, available worker node independently. There we have the dependency, that is nothing but the kubelet. So but kubelet is comes from the worker node. Let me write here worker node as well. Second one is, we have the pending point is control manager from this control node, okay? But let me write here worker node. So worker node have kubelet. Wait, guys. Worker node have kubelet. Then what does kubelet, guys? Kubelet is nothing but the node agent. Kubelet, this is our kubelet, right? So what does the kubelet, guys? Kubelet is nothing but the node agent, right? So every worker node have one kubelet. This is our kubelet for this worker node. This is our kubelet for this worker node. If we have the worker node, 5 worker node, every worker node have the kubelet. So kubelet is nothing but the node agent. It will help us which worker node is a free or which worker node is a busy with our incoming task or in process task, right? So kubelet is going to communicate with our scheduler, and scheduler will knows about this this worker node, guys. This worker node is a busy or not, this worker node is a busy or not, right? Accordingly, kubelet is going to communicate with the scheduler, and scheduler will assign this request to the worker node second, because scheduler have the idea about this second worker node, because second worker node is a free and first worker node is a busy in the in process task. right? So how scheduler will know about this one, guys? By using the kubelet. So kubelet will know about this worker node task. If this worker node is a busy, then kubelet will not going to share the details. I mean, send the details to the scheduler, right? If this worker node is a free, then this kubelet is going to communicate with our scheduler, and scheduler will assign the request to this worker node, right? So kubelet is called as, let me write here, kubelet is called as the node agent, right? Node agent, it will maintain all worker node information. Node agent is nothing but it will maintain, all worker node info, right? So every worker node information is available in the kubelet. Accordingly, kubelet is going to communicate with our scheduler, and scheduler will assign the request to the worker node, right? Then here we have the kube proxy as well, right? Then what is the kube proxy, guys? Kube proxy will provide the network for this cluster communication, because this is our cluster, this is our complete cluster, guys, right? This is nothing but our complete cluster, right? Now in this cluster we have the worker node, right? In this cluster we have the master node as well. For this communication we have the kube proxy, and kube proxy will provide the network for this cluster communication. Let me write here what is kube proxy. Kube proxy is nothing but it will provide the network for the cluster communication, right? Are you guys understood about this kubelet and kube proxy? Any doubts on it? We have the rest of this point, okay? We will discuss about this control manager last, okay? So kubelet is going to, is nothing but the, I mean, node agent, and there in the node agent we have the information about this worker node. This node agent have the information about this second worker node, right? Then kube proxy is going to provide the network for the communication of this cluster, internal communication, right? Because this is our master node. Master node is going to communicate with our worker node, and for this communication we required here the network, guys, and this network is going to provided by this kube proxy. Any doubts on it? Are you guys understood about this point?
This
Everyone?
kubelet is
Sorry.
kubelet is going to give the information of that node
Yeah,
to the
right.
scheduler, right?
Right.
The kubelet is going to reserve the resources for that pod, or it is
No, no,
only
no. It is
giving
reserve the
information to
resource.
the scheduler.
No. Only information of this node. So node have the information about this container, right? Which container is a busy? Which pod is busy,
Okay,
right? So node have every information, and this node information is going to store inside of the kubelet. So kubelet have the
okay, then
complete information, right?
okay, then it is not going to reserve the resources for that pod. Then scheduler
Exactly.
going to
Hmm.
schedule a pod on that worker nodes based on the observed, like whatever CPU or memory. Based on that,
Right.
it is going to
Exactly.
schedule a pod on that pod. All
Right.
right.
Right. Right. Right.
Then
Exactly.
my doubt was that who is going to reserve that particular resources to the pods.
No, the pods are up according to the number of requests, right? We have the small request or we have the less request, accordingly pod is going to up, right? So pod is nothing but the server, right? Server information is available with the node, and node information is available inside of the kubelet. So kubelet will know about every information about this pod, which pod is busy, which pod is available. Accordingly, kubelet is going to communicate with the scheduler, and scheduler is going to assign the request to the second pod, right? So second pod contain only one container, third pod contain the two container. Now here we have the load balancer, right? Because the load balancer is knows previously we fire the request to the container first. Now this time we need to give the request to the container number second. Instead of this, load balancer is comes into the picture. So kubelet only knows about the node information. Node information is nothing but how many pods are available and how many pods is in process task. How many pods are busy with the task? If 3 pods are busy with the task, then kubelet is not going to assign this worker node to the scheduler. And here we have the 2 pod is busy and 1 pod is a free. Now kubelet is going to communicate with our scheduler, and scheduler will assign the request to the third pod here. Understood?
Yes.
Okay. So everything is managed by this kubelet instead of the, because worker node information, every information available inside of the kubelet, guys. So kubelet have the better idea which pod is free and which pod is which pod is busy with a in process task. Sir, the
So then
number of containers
kubelet,
yes.
yes, please.
Yeah. So inside of this pod, we have the auto scaling process and load balancers comes into the inside of this pod, guys. Every pod have the auto scaling and load balancing. So why here we have this one container, guys? So Google already, share this diagram. Why here we have this 3 container, guys? Because the requests are coming on this pod, right? The maximum requests are coming on these pods. Accordingly, auto scaling will increase the number of requests. Sorry, number of servers. Later, we have the load balancer will distribute the request to the container first, container second, container third. Then what is the container? Container is a server, right? It is a packaging our application code and dependencies. Everything is available here, right? So load balancer will distribute the load. Now let's suppose scheduler no kubelet is assigned pod number to the scheduler. Then scheduler will assign the request to the pod number 2. Then pod number 2 we only have the container first, right? Then here we don't have the here we don't have the load balancing. Automatically the request is going to transfer to the container first. And let's suppose again kubelet is going to assign the pod number 2. Then what will happen? We only have the container first. Let's suppose we have the 100 requests are coming to the pod number 2. Then what will happen? Auto scaling again increase this pod container, right? Auto scaling is up this container first, this container 2, up this container 3, right? Here also we have the lots of requests are coming for this pod number 3. Then what will happen, guys? The container is going to increase, right? Scale up the container, right? If we don't have any much more requests, then automatically auto scaling will decrease this container, decrease this container, and decrease this container. That's why Google is showing here the 3 container. Here we have the first 1 container. Here we have the second 2 containers, right? So in between those container, only scale down because we don't have any lots of requests here, guys. Are you guys understood where our load balancer and auto scaling comes into the picture?
Yes, I got the point. I got another doubt is like,
Yes.
suppose like kubelet is only maintaining the information of the nodes, right?
Mm-hmm.
Then who is going to interact with the container runtime to pull that image and run as a container?
See, everything is managed by the everything. Inside of this, we have the network. We require the network. Okay. So every managing work is done by the Kubernetes. Okay. So we have this setup architecture. We don't have any do it by manually. So you thought you are going to thinking about the who is going to manage this one, because everything is up to date here. We have the kube proxy will communicate with okay, kube proxy will provide the network over this communication. Now kubelet is have the information. Now kubelet is knows about the which one is free, which one is busy. Accordingly our request is going to assign to the number of pods, according to the pods, right? Now the request is going to pull. Your question is who is going to request, pull this request, right? What is your question? Comes again.
My question is like, who is like in that which component is going to interact with the container runtime?
Right. Yeah.
The container runtime only like going to pull our image from the registry, right?
Okay, I got your point.
Uh,
So in the backend application, we have the YAML file. Okay, it's nothing but the YAML file, or I guess we have the shell scripting file. SH file is available. Application.sh file, and this application.sh file have the better idea about this information, guys, because everything is managed by this shell scripting, guys. So shell scripting have the better idea how much worker node is going to up, right? We can enter the number of node information inside of the sh file. So in the sh file we can write, we require the 3 nodes here. Accordingly we can write the 3 nodes. Accordingly our nodes is going to up. So everything is a linking with our sh. Once we can try to deploy our application, then I will show everything. Okay, because some of the configurations are available in the sh file. Okay, so once we start the deployment, then I'll show you everything, guys. I understood about your doubt, but when we start for this sessions, deployment, then I will show you everything. Okay, so meanwhile just keep in your mind about this architecture. What is the role of this API? What is the role of the scheduler? Because internally, lots of things are going to handle by this backend, guys. How communication will happen, how container is going to up, how worker node is going to down, how worker node is going to up, right? How image is going to pull by the kubelet, how communicate with our kubelet to the scheduler, right? Later, how Docker platform is going to work, everything is managed by the sh file, guys. Okay, so I'll show you the real-time sh file. We will try to create it, but this is not possible for this session, guys. So next week we are trying to deploy our application by using the sh file, because in the sh file lots of important things are added there. We have some variables, we have some keys are available. Accordingly our kubelet complete architecture is going to work. Okay, I'll show you everything. Meanwhile, just keep in your mind, what does pod, what does Docker, what does kubelet, what does kubeproxy. Are you guys clear about this point? Mm-hmm. Yep. Yes. Yes. No. Yes, guys.
It's
Any doubts?
clear.
Yeah. Okay. Now, kubelet kubelet is nothing but the node agent, right? Then kubeproxy is nothing but the network. Kubeproxy is going to provide the network, right, for this cluster communication, right? Now the Docker is nothing but the containerization platform here. Now let's discuss about the control manager, guys. Then what does the control manager? It will verify all the tasks are working as expected or not. It means whenever CLI, we have the user request are coming from the CLI, then control plan, instead of the control plan, API server will receive the request or not, which are monitored by using this control manager, guys. This is nothing but our manager. And manager, what does the manager, guys? In every company's manager is going to assign the task, or manager is going to check every developer is going to work or not. Every developer is giving the task are completed or not, right? It means controller manager will check the API server has received the request or not. Accordingly, API server is going to transfer the request to the etcd. Again, control manager will check etcd have the incoming request or not, or again control manager will check the what is the state of this request, pending or incomplete, pending or completed, right? Accordingly, scheduler is working as expected or not. So everything is managed by, or everything is going to check by the control manager, guys. So let me write here controller manager, right? So controller manager is nothing but it will verify will verify will verify all the what we can say that all the task, right? All the tasks are working as expected or not, right? So this is managed by the control manager, guys, right? So this is nothing but the control node. Control node is a master node. It contains the API server, will receive the request, store inside of the etcd. Scheduler will check the pending request and assign to the worker node. Control manager will verify all the tasks are running as expected or not, right? Then we have the worker node, right? This is nothing but our master node. We have the worker node. Worker node contain the kubelet. Kubelet is called as a node agent. Kube proxy, it will provide the network over the cluster communication, right? Now, here we have the pod as well. Then what is the pod, guys? This is very, very important, guys. What does the pod? What is the pod, guys? Pod is nothing but the smallest building of block that we can create in the Kubernetes cluster, right? Pod is nothing but the smallest building block that we can create inside of the KTS cluster, right? Inside of the KTS cluster, right? Then inside of the pod, Docker containers are available, guys, right? Pod is nothing but the smallest building of block, right, that we can create inside of the cluster, right? So pod contain the containers, and containers contain the containers is nothing but our application, right? So let me write here, pod contain the containers, right? And those containers are up and down by using the auto scaling, and on this container our requests are distributed according to the load balancing technique, guys, right? Now pod is nothing but pod contain the Docker container, right? Pod contain the Docker containers are available here, right? Pod contain the Docker containers, right? So that is called as a pod, and every pod have the number of containers available according to the request, incoming request, right? So guys, this is our, I mean, everything is done here about this architecture. We have the kubectl. This is nothing but the CLI. We have the control plan. That is nothing but our master as well, master node. So control plan contain the API server, etcd, scheduler, control manager. Then later we have the worker node, and those are managed by using the shell scripting. Okay. So developer have the responsibility how many worker nodes, developer have the accessibility about this worker node, guys. How many worker nodes that we required here for our application deployment, accordingly shell scripting is going to manage by those nodes, right? Later we have the container. Now in our application, our Docker images, for our application our Docker image is going to Docker image is created, and those Docker image are deploy on this container, and those container also which are managed by the shell scripting, right? The name of this container. Later how we can pull this Docker container image, and how we can transfer this Docker container image to the load balance, to the server, that we can discuss about this, that we can discuss with the help of this shell scripting, guys, in the upcoming session. Okay, because this is our completely theoretical session, that we know about how Kubernetes architecture is going to work. Whenever we can start for this installation and installation and deployment, that we have some of the words are, some of the pods are available there, containers are available, then we have the API server also there available. So before there you should know, before the deployment you should know how our application is going to deploy, and what is the meaning of this pod, what is the meaning of this kubelet, where kubeproxies comes into the picture, how Docker platform is going to up, right? And containerization platform, and later how containers are going to manage by this containerization platform. Everything that we can, that we can see with the help of this shell scripting file, guys. Okay, without this we cannot do anything, because this worker node is going to handle by the developer. So developer have the accessibility how much containers, developer have the accessibility for this how much nodes that we required here, right? And how we can communicate with this Docker containerization platform to the containers, right? So every information is available in the shell scripting file. So I'll show you everything, that we already have this application, deployed application, but we will see guys step by step. Okay, so before this upcoming session, upcoming week session, you can try to understood about this architecture first. I'll share with you the notes as well. Accordingly you can start your preparation for this. So because interviewer is not going to ask to you to try to deploy application in front of me. interview is going to ask only that like of question. What does the API? What is this container? What is this Docker? What is this kubelet, kube proxy pods, right? Who is going to handle by those worker node? How we can create the number of worker nodes? If we require the 5 worker node, then how we can manage it? So that we can manage by using the shell scripting. Okay, that's we can this is possible to create those worker node by using the shell scripting file. Okay guys, any doubts on it? Are you guys understood about this Kubernetes architecture? What is the architecture? What are the advantages of this Kubernetes? Everyone? So now you can ask me the question if you have anything for this architecture, guys. Yes, Asim, Nawaz, Pavan, Randhir, any doubt? Okay, so in this upcoming session, we can start for this deployment part of this application by using the Kubernetes cluster. So, right. So first of all, we need to do it by practically. We need to complete it, this architecture with the practically by using the AWS cloud. So we required here the cloud services. EKS is major service for this Kubernetes. This is nothing but the Elastic compute. I mean Elastic Kubernetes server. So accordingly, we can create the worker node and master node as well, right? So also we required here the Jenkins because we need to build our application automatically by using the Jenkins, right? Later we can try to install, I mean, server as well. Just give me a second, guys. Yeah, sorry, guys. So accordingly, how we can manage it by using the AWS cloud, right? How we can create the worker node, how we can create the master node, everything that we can do it by practically, guys. Okay. So this is our only theoretical session because I mean, before going to the Kubernetes practical session, you should know everything about the architecture. And definitely interviewer is going to ask the question about this architecture. Definitely. If you are going to write, I have the hands-on experience on the Kubernetes or I have some exposure on the Kubernetes, every interviewer is going to ask that like of question. What does those parameters, right? Those services. Okay, so let me tell you one thing, guys. So we'll provide the notes in our workshop WhatsApp group. So you will get the certificate as well for this Kubernetes session. Later, we will provide the recording session on the WhatsApp group and you can connect our LinkedIn account. You can follow the LinkedIn account for our upcoming practical sessions. Okay, so everything is we are trying to like give you the demo. I mean, we're training on the every major services, every advanced technologies. Okay, so for that you can try to log in. I mean, try to connect with our LinkedIn account. You can follow the LinkedIn account. Accordingly, you will get the more information about our upcoming sessions. Okay. So if you have any doubt, then you can ping me on the WhatsApp group. There you will get the notes as well by today only for this architecture. I mean, everything about this architecture, what does the pod and everything. So you can read yourself. And in this upcoming session, upcoming week, we can start for this deployment, guys. Kubernetes deployment. Okay, I hope everyone can understood about this point, guys. So if you have any question, then you can reach out to me by this WhatsApp group, guys. Yeah. So thank you so much, guys. Thanks for the join. Thank you very much.